All right, here's another problem to help with shear and moment diagrams. All right, so basically what we have here is we have a reaction here, which I'll call AY. We have a reaction here, which I'll call BY. And then what we have here is like a 1.8 kilonewton force on the left. That's 260 millimeters from the center. And then 6.4 kilonewtons acting downward from here. So what we're going to do is we're going to move these two forces at C. Okay. So what we're going to have is a downward force we're going to call CY, and then we're going to have a moment, which is MY. And pretty much we'll get rid of that. Okay. So CY is going to be the difference between them, 2.64 kilonewtons minus 1.8 kilonewtons. So this becomes 0.84 kilonewtons, okay? And then the moment, I'll do this in red, at Y, is going to be 2.64 kilonewtons times 0.26 meters plus 1.8 kilonewtons times 0.26. So this now, and we're assuming this way is positive, is 1,154 Newton meter. Okay? So we pretty much have now converted this T, sorry, I gotta sneeze, sorry, to a CY and an MY. Okay? All right. So now what we can do is we can sum the forces, we can sum the moments at A, set it equal to 0. So we have BY times 1.2 meters minus, we're assuming this way is positive, 0.84 kilonewtons times 1.6 meters, right? Because you got 1,200 plus 400, minus the moment at C, which is 1.154 kilonewtons equals 0. Okay? And that's a positive. So we have the force, we have BY, we have CY, and then the moment we have to add into here. So BY becomes 2,082 newtons. Okay? And then we can sum the forces. In the Y, set that equal to 0. We have AY, we'll assume upward is positive, plus BY minus CY equals 0. We have AY plus 2082 minus 840, right, equals 0, and AY equals negative 1242 newtons. So it's actually acting downward. Okay. So this is how you would set this up, and I'll do the shear moment here in a second. Just move these forces, and if there's a moment, move it down to point C. Okay? And then use those in your moment equations and your forces to find your reactions. So let's look at the shear and moment diagram. So we got V newtons. Okay, so AY is actually going down. So it goes down. This is negative 1242. Okay, and we'll do this as point A. And then let's pick, let's do it kind of right here is point B, and then here is point C. Okay. So it's going to be 2,082, so it's going to go over to B, and then it's going to go up 2,082, and it's going to hit right here, which is 840, right? Because that's what CY is, because it's going to go over and then back down, because CY was downward. Okay, so you have that shear. Okay, this is 840. So AY is downward, so you go downward, you go over to BY, because there's nothing else between A and B. So then you go upward 2082, because that's what BY is, to get 840, because that's what CY is, and then you go back down. Okay, now the moment, and then I'll kind of do these light lines here. Moment, Newton times a meter. Let's go with red. So there's no moment at A, all right? I think that's part of the problem. Like in the problem, it says no moments at A for that instance. And we just got to figure out what the area of A to B is from the shear diagram. Okay, so it's going to be a linear because it's a rectangle. It's going to be linear down to here, and this value is what, 1242 times 1200 millimeters. Okay, so this should be minus 1490. All right, and let me double check. I'm pretty sure that's what I had in my calculator. Let's see, it was negative 1242 times what, 1200. So 1.2. Yep. So 1242 times 1.2, because I converted it to meter. And then take the area from B to C, which is, and it's going to be positive, so that's 840 times, what was that distance? 0.4. Okay. So we're going to go up 336, because that's the area of B and C. So add that to negative 1490. And this should be somewhere here, and this value is 1154. Okay. And then it's going to go up, right? Because there's no moments. It balances, because the moment that we calculated at the start was 1154, right, at C. So we're going to go up 1154, and boom, we're back to 0. Okay. So that's your moment diagram. Again, from A to B, you take the area. It's a linear line. Sorry. And you get 1490. Then take the area of BC and add that to 1490. So the area of BC is 336. So you're going to go up in the positive because the shear is positive to 1154. And then you're going to draw a vertical line up to 0. Because we have that moment left that we calculated at C. Okay, so we have to add that back to it. All right, I hope this helps. And if you have more questions, let me know.